Okay, pre-calculus. We're continuing in Unit 5, and we are on day 3 notes, continuing to solve trig equations. So here we've got the Pythagorean identities, and I have a little note on the side here, not on the formula sheet to memorize. Sometimes I'll hand out a formula sheet in class, and you just need to make sure you have those. Those are formulas that are not usually put on a formula sheet if you're using one in class for quizzes and tests. So the way, mostly people remember that sine squared plus cosine squared equals 1, and we've been over that numerous times. However, these two are less used but are very useful. And the way I remember them is that the tangents and the cotangents go with the 1. So the cotangent, 1 plus cotangent squared is cosecant squared, and then tangent squared plus 1 equals secant squared. So let's see if we can't do some of these problems. You're going to see just how much practice I normally give my class when I do this in class. So if you have a problem like here where you see you've got sines and cosines in the same equation, and one is squared, go ahead and try to rewrite the squared term using one of the Pythagorean identities. So if I've got, and I've done this for you before, if you've got sine squared plus cosine squared equals 1. Okay, if I want to isolate that sine squared, I can just subtract cosine squared from both sides. And you could do the same thing with the sine squared to isolate the cosine squared. But in this case, now I can substitute 1 minus cosine squared in for sine squared. And that was what I did in the first step. And here they're using theta for the angle, not x. The next step is, well, now we've got a 1 and we've got a cosine squared, and we've got over here, if you distribute 6, you've got a 6 cosine and a 1. Let's shove everything to the same side. Now I've got a trinomial. So if you consider those cosines to be like x's, x squared plus 6x plus 5 equals 0, what would you do? You'd factor. We're doing the exact same thing here, except instead of x's, we have cosines. So you factor, use the zero product property to separate each of those factors and set them equal to 0 and solve, and you find that cosine is between -1 and 1, if you're just thinking of the graph. So cosine is never going to equal -5, no solution. Where does the cosine equal -1? At pi. And we're writing the general form of the equation, so that's theta equals pi plus 2 pi k. Let me pause and get these dogs out of here. Okay, so normally in class here, this is where I would go to say, try questions 1 and 2 in the classwork. And again, they're in my Google Drive if you want to take a look at them before you move on. So we're going on to a different type of equation. So now you've got, sometimes you'll get angles that don't match. So here we've got an angle that's 2x, and here we've got an angle that's x. Okay, so when they don't match, try using the double angle formula to rewrite the equation so that they do match. These formulas are normally on the formula sheet. So here I've got two angles that don't match. So if I can rewrite cosine, this is 2 theta, cosine of 2x, if I can rewrite this as cosine squared minus sine squared, cosine squared minus, here's my sine squared rewritten using the Pythagorean identity, just like the problem above. So if I plug in 1 minus cosine squared, now what I've got is I've got an equation with cosine squareds and a cosine, which would be a middle term for a trinomial, and a number. So I'm just going to distribute this negative. Okay, so that becomes a -1 and a plus cosine squared. So that means I end up having 2 cosine squareds and a 3. So if I move this 5 cosine over to the other side, now I've got a trinomial that I can factor just like normal. Set them each of the factors equal to 0 and solve. And using the unit circle, obviously we'll have no solutions for cosine of theta equals 2. But where does cosine equal 1/2? It's at pi over 3 and also 5 pi over 3. So those are your general form of your solutions. If you'd like to try practice on that, you can go to question 3 on the classwork. And again, that's all in my Google Drive, and so are the answers. Moving on. So if you've got a problem where you cannot separate the sines and the cosines, see if you can rewrite it by squaring both sides. So here, this equation A, we've got a cosine on the left and a sine on the right. And here we've got, again, similar, okay? So we're going to square both sides. When you square both sides, this one is one term. So that's just going to be √3 times sine times √3 times sine. √3 times √3 is just 3. Now this is a binomial, which means that you're going to have to multiply binomial times the binomial. You're going to have to FOIL that puppy, okay? So Usually I don't write that out, but once you have it FOILed, that's what you'll get. You'll have a trinomial. Now I've got a sine squared, and I've got a cosine squared, and I've got a middle term that's a cosine. Well, that's kind of an issue for me. So what I'm going to do is I'm going to rewrite this sine squared as 1 minus cosine squared. So now I've got an equation with a whole bunch of cosines. I've got some that are squared and some that's a regular cosine and then a number. So I can distribute my 3 to my 1 and to my negative cosine squared, and then shove everything's already on the same side, and then I can add all the like terms together. So now my leading term should be this negative 4 cosine squared, right? So I've got a trinomial here. I'm going to factor out a negative 2. I like my leading factor, my leading number in front of cosine squared. That I really like that to be a positive number. So I'm going to factor out a negative 2. You don't absolutely have to do that. And once you get into, before you get into pre-calculus, they really like your leading coefficient to be positive. So I still do that, but it doesn't really matter at this point. If you left it in and you factored from there, you still get the same answers that we're going to get right here. Okay. So I went ahead and I factored out a negative 2, and then I factored and then solved for theta here using the unit circle. When I did that, I ended up with 3 solutions. However, we've got to make sure whenever you square, especially when you square both sides of an equation, you have to check for extraneous solutions. And that happens quite often when you square both sides of an equation, okay? Funky stuff starts happening. And it'll be easier to show you that in this one when I do A. However, here, if you go ahead and you plug these values back in to the original equation before it was squared, okay, so if you do square root of 3 times sine of theta, and I put in this 4 pi over 3, which is why I cross this out. If I substitute in the 4 pi over 3, I'm going to end up with a negative 3 over 2 on this side and a positive 3 over 2 on this side. That's why 4 pi over 3 doesn't work, and it's an extraneous solution, okay? Let me show you. So basically, your solutions would be just those two. And we're not solving on an interval, so we're using the general form of the equation. All right, so let's do A. So I'm going to go ahead and square both sides. And I know I'm going to have issues with this one when I square both sides because, you know, if sine and cosine are sometimes negative and sometimes positive. So when I move that sine squared over to the other side, I mean, the cosine and sine aren't always equal to each other, right? They're only equal to each other in some quadrants. So I'm going to substitute that sine squared for 1 minus cosine squared. Oh, my handwriting. So now I'm going to distribute that negative, and that will lead me to, I'll have 2 cosine squared. Did I just change my alphas to x's? I did. It's fine. It's fine. That's an alpha. That's an alpha. Okay. Minus 1, right? Equals 0. So if I add 1 to both sides and divide by 2, I will get the cosine squared of alpha equals 1/2. Now, if I take the square root of both sides, okay, how do I find the square root of 1/2? So if I go to, oh shoot, how do I get to my flip chart? Another page. It's fine. Everything's fine. Square root of 1/2. Okay, so that's equal to the square root of 1, that's a 1, over the square root of 2, that's equal to 1 over root 2. Rationalize, I'm getting root 2 over 2. All right, so that's where this comes from. Shoot, where was I? Oh my gosh. Okay, found it. So now we've got cosine equals plus or minus, because we're taking the square root of both sides, and that's going to technically be the absolute value of cosine. So that's root 2 over 2. Now, where does cosine equal positive or negative root 2 over 2? Well, that's middle angles, right? And that could be any of those middle angles. So, knowing that, general form of your equation is going to be pi over 4 plus, and then there's the distance between each of these is the same, pi over 2, pi over 2, okay. Now, we've got to have some extraneous solutions because I know that sine is y and cosine is x, and they're only the same signs, and that's what the original equation says, that they're equal in quadrant 1 and quadrant 3. Because in quadrant 2, I've got x is negative, y is positive. And in quadrant 4, x is positive and y is negative. So the only time they're ever the same, that's only true in quadrant 1 and quadrant 3. So I'm going to say alpha equals pi over 4 plus pi k, and then that's only going to be true if we were solving on an interval. Well, let me see. And we're not solving an interval, so there we go. So the difference between this one and this one is this solution includes all of the quadrants. This one only includes quadrant 1 and then quadrant 3. Okay? All right, so now we are moving on. You might have to, if you want to try question 4 in the classroom, feel free, because if we were in class right now, that's what you'd be doing. Oh my gosh. All right, last one. These are kind of fun, aren't they? I think they're kind of fun. Okay, so here we're adding fractions to solve the equation. Okay, we're just trying to give you different ideas and so you have different tools in your little toolbox here. So when you come across a problem, you might remember these different types of tools and different ways to do things. All right, so adding the fractions to solve an equation. So we're still in this section here. We try to square both sides and check for extraneous solutions. But here we've got, oh wait, hold on a second, I'm confused. Let me back up. Using Pythagorean identities to rewrite the part of the equation. And then we did using double angle formulas, okay? And then we did squaring both sides. Okay, and now we are on, adding fractions. Okay, so if you've got two fractions, here we've got a denominator of cosine. Here we've got a denominator of 1 plus cosine. So how would you normally do that? You would multiply each of the two fractions. I'm going to multiply this by 1 plus sine of x over 1 plus sine of x. You need to know how to basically find a common denominator each side. When you do that, here's what you end up with, this next step, okay? Because this is you're multiplying 1 plus sine of x times 1 plus sine of x. So you get 1 plus sine of x squared. And that's over cosine of x plus 1 plus sine of x. Over here, cosine times cosine is cosine squared. Okay, so now take a look at that. I mean, we already know this is not working. Okay, when you FOIL this out, you're going to, because this is a 1 plus sine of x and then times 1 plus sine of x, you've got to FOIL all that out. And in doing so, you have all of these terms here plus this cosine squared. Now, we know that the sine squared plus cosine squared equals 1. So this ends up just being 2 sine of x plus 2. If you factor that 2 out, we end up with 1 plus sine of x in the numerator and 1 plus sine of x in the denominator that will cancel because this is a factor and this is a factor. These are all factors. They're being multiplied, so we can cancel them. We still have that equal to 4. And when you solve this equation, 2 over cosine of x equals 4. Okay, I'm just cross multiplying. Think of that as like over 1. Shoot, why is this not working? There we go. When you get 4 cosine of x times 2, divide both sides by 2, you end up with cosine is 1/2. Where is the cosine equal to 1/2? We've got it at pi over 3 and 5 pi over 3. And then you just want to check your domain restrictions and make sure that you're not coming up with any solutions that would make the denominators here equal to 0. And sometimes I do that at the beginning, and sometimes I do that at the end. But today, I'm checking them right at the end here. Okay, so we are good. So here we go. And if you'd like to, you could try question 5 on your classwork. So here's what the classwork looks like. This is solving trig equations classwork, and it goes through several different types of problems here and in different ways as well. So take a look at those if you feel, and I'm finished. Peace out.